Okay, so now what I want to do is after I've done my first part of my gear car, we need to start thinking about the gear ratio that I want the car at. Okay, now again, my design that's on the screen right now, really it was started up from the calculations of the weight based upon the model I was coming up with. Unfortunately, we didn't get to this stage, so I'm going to go ahead and just kind of let you pick your gear ratio. I like it to kind of keep it between like a 30-to-1 and 60-to-1. Mine, I think, is a little bit more based upon what I was doing with mine, because it's a little heavier. But I do want to talk to you really about how do you calculate a gear ratio. Hopefully by now you've already watched the video number 1 and 2 of wheels and gears. Okay, at least gives you a rudimentary understanding of how gears work, how it amplifies the torque of the motor to the torque of the wheel. Okay, and that's what we're trying to do here. We're trying to create or amplify the very small amount of torque in the tiny motor to a point where it can turn the wheels at the back or front of the car and be able to push this heavier vehicle up a hill. Okay, now doing a gear ratio, as you can see mine right here, I have a 13, a 38, a 13, a 38, a 13 to a 38, 13, 38 to a 58. Okay, so what that's basically showing you, these are what's called a compound gear ratio, right? I'm stacking gears on top of each other. What I mean by that is I literally have a 13-tooth gear on my motor, and it is intertwined with a 38-tooth gear right here. Now, glued to that 38-tooth gear, where I'll have an axle probably going through here somewhere, so I'll have to create some kind of a holder. I have glued to this 38-tooth gear a 13-tooth gear. So when the 38 spins, so will the 13. That 13 then is driving what I call a 38-tooth gear. Now, these two are not glued to each other. Okay, this is independent of this one. However, I have another 13-tooth gear glued to this one. So when this 38 turns, so does this 13, which then turns this 38, which has a 13 glued to it. Okay, so when it turns this 38, ultimately turning the 58 tooth at the end. You're like, holy moly, Mr. Combs, that is a lot of gears, and that is confusing. What is the gear ratio? Well, let's go through that calculation. I want to walk you through how to actually calculate this. Okay, so you got to remember that gear ratio is driven gear over the driving gear. All right, so a driven gear is, or a driving gear is the one forcing the driven gear to move. All right, so the driving gear, so we start from basically the motor and work our way out. So my motor's sitting right here. Okay, so the first thing I'm going to say is, all right, the driving gear for the first one is 13, and the driven gear, or put it this way, the driven gear is being, the 38-tooth gear is being driven by the 13-tooth driving gear. Okay, I hope that wasn't confusing. So the way you'd write this is 38 divided by 13. Okay, now, as you go through this, I'm going to actually create a little space here. And then I'm going to look at the next gear, okay? So this 13 is driving this 38, or this is a driven gear. Now, when this gear spins, this gear is spinning. So now this gear here is driving this gear here. So the 38 is being driven by this 13-tooth gear. So what that means, I have another driven gear is a 38. The driving gear again is 13. Okay, let me give a little more space here. All right, then if you think about this, as this one is turning, now this one is turning. So what's happening is this 13-tooth gear here is now driving this 38-tooth gear here. Okay, so in this case, again, I have a driven over driving. 38 is being driven by the 13. Create a little more space here. Okay, now this gear here is spinning, which is causing the 13-tooth gear here to spin. So now this gear is driving the 38-tooth gear here. So this is driven, this is driving. So that driving gear is 38 over 13. Okay, now, excuse me, got one more. Okay, now this 58-tooth gear is being driven by the 38-tooth gear. So the last gear ratio I had is a 58 driven over the 38 driving gear. Okay, so 58 divided by 38. Now, How do I figure out my gear ratio? Well, when you have these, all this becomes is a multiplication problem. You take each one of these and you begin to multiply them. Okay? So you have a 38, 38, 38, 38 times 58 divided by all this at the bottom. So what this looks like then is as follows. Okay, so I'm going to just say equals, and what you're going to get is 38, excuse me, let me do something real quick. I want to try to put this together so it makes more sense. I'm going to take and copy this real quick. Do a quick copy. Try to copy, Control C. Bring this down here to Control V so you can see kind of more of it as a mathematical model. So the top line, I'm going to put the following. Okay, I'm going to highlight this. I'm putting in the following. 38 times 38 times 38 times 38 times 58. And on the bottom, I'm going to have 13 times, sorry, let me correct that, sorry, let me get this done. Come on, work with me, Goose, here we go. There we go. 13 times 13 times 13 times 13 times 38. Okay, so this is your big equation. All right, now you take your calculator out, you can figure all this out real quickly. Space there, equals, and you can start adding this all up. Okay, so if I take my calculator, I'm going to actually get this going. You can take and double check me if you would like. Take my calculator, and I'm going to get 38 times 38 times 38 times 38 times 58. I get the following. Okay, so again, I'm just going to kind of put this in perspective. I'm going to copy this one more time. Sorry, Control copy, put this over here. You do not have to do this. I'm just showing you how this all plays out. You figure this out on pad and paper. Okay, so this comes out to 120,937,888. Okay, the bottom then, I'm looking at this bottom number down here, is the following. 13 times 13 times 13 times 13 times 38 equals 1,085,318. All right. So what that means is if you take that 120,937,888 and divide it by 1,085,318, I get a gear ratio of 111.43 to 1. Okay, as you can see, that is pretty high. It was over 100. So looking at this, I'm probably going to readjust this. Like I said, usually if you hover around 50 or 60 to 1, especially if it's a larger car like mine, you can make this work. Okay, so what that probably tells me is I have one too many of these 38 to 13s. So I could probably end up getting rid of a couple of them. So this is the game you can play. Let's say I get rid of this one here. Let me just play this out and see what I get. If I get rid of one here, so just give me a second. I'm going to cross that one off because that would be this one here. And I get rid of this one here and basically bring these all in tighter. Okay, so again, this is a game you got to play now as you start designing your gears. And hopefully this is making sense of how I'm applying this. So I get rid of those. Okay, so that means I'm basically getting rid of this one here, cross that out. I get rid of this one here, cross it out, get rid of this 13 down here. Okay, again, if I was doing this on pencil and paper, I would just erase these or start another line. And essentially now I become to get this. Okay, I'd go in here and say, all right, let's just do real quickly, take those off of there. It gives me a new answer here. So let me just put these numbers in and come up with a new gear ratio. And this is, again, like I said, the game, God dang it, you got to kind of play. It's a lot of trial and error to get the gear ratio just right. So I'm going to do a 38 times 38 times 58. Okay, that's a little bit smaller number, 88,000. 752. And I'm going to get rid of the bottom, which is going to be a 13 times 13 times 38, which is 6,422. Okay? If I divide 88,752 by 6,422, I get a gear ratio. Now that's way too low. I get a gear ratio in this case suddenly of 13.82 to 1. Okay, so now that's obviously too low. So now what I may need to do is keep one more of these on here and just kind of reset it up a little bit differently. So I'd have to do something here. Maybe this one here. And then maybe this one here. And I may have to flip my gears the other side. So this is where the game is. I have to redraw these, okay? So if I tried that, let's say I end up coming back and saying, you know what, I need this 38 to 1. This is where you have to get creative with your design. I may have to go back and rethink this a little bit, okay? Like I said, last year I went a little bit high just because I had a lot on there. The car weighed over a pound. I'm just going to tell you up front that in the initial design, because I had a top piece for a drop device that was 3D printed. The 111 to 1 would be okay. But again, if you're looking, I'm at 2, 4, 6, 8, 9 gears. It's a lot of gears. I prefer to stay down in the 5 or 6 range. So again, maybe what I'll do is add 138 right there. I'll uncancel that one, come down here, uncancel this one, and then try one more time and say, okay, let's see if I can get this to work. Now the downside to this is then I have to restructure my gears. But this, again, is where I can play that game a little bit with SolidWorks. I can move things a little bit more freely than I can on paper. Now, I wouldn't hesitate to sketch this out. Before I even start building this, I will tell you when I'm done with this little presentation, I will re-sketch what you see here. Okay, I'll just do a very rough paper napkin sketch of how I want the gears to play out so I can make sure that my 58 tooth is back here and not over here. All right, so that's kind of the game I got to play a little bit. I can maybe also see what happens if I got rid of this 38 and 13 right here. If I went this one, this one, this one, boom, 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 boom. Yeah, I'm not sure if I can get that to work, or if I went from a 13 to 38, a 13 to a 38 directly into a 58, that could possibly work. So it'd be a 13, 38, 13, 38, 13, 58, 13. We just did that one. That's too low. So in this case, I'm going to try one more time and see what this ratio gives me. Okay. And then at that point, I'm going to let it play out a little bit. I may have to fudge my numbers. Again, only gears I'm using are my 13, 18, 38, 58. You're more than welcome to use any of the other ones that we designed. You can also design your own. This may be a great one where I should customize my own gear in order to make this work, to get my gear ratio to 50 to 1 or 60 to 1. Okay, but I'm going to try this one more time, and then I'm going to stop the video here. Okay, so 38 times 38 times 38 times 58. All right, so it gives me a little bit bigger number. That's 3,182,576. With the bottom number going here, I got 13 times 13 times 13 times 38. Give me 83,486. Okay, so now if I plug that in, 3,182,576, and divide that by 83,486, I get a gear ratio, oh, that's a little bit more reasonable, of 38.12 to 1. So this looks like a pretty good gear ratio right here. That's about what I'm shooting for, almost 40 to 1. That's not too bad. Okay, now the hard part is knowing this is kind of the gear ratio I'm looking at here, okay, knowing those numbers, 38 to 13, 38, 13, 38, 13, and the 58 to 38. Now what I have to do is go back and restructure how these gears mesh together in order to make sure my 58 tooth is back here in the backside here. Okay, the nice thing is I'm basically eliminating 2 gears, so instead of 9, I'm down to 7. If I can find a way to even go lower, I will. Okay, I wouldn't hesitate to go 13 to 58ths. Quick way to amplify your gear because a 58 to 13 is much higher ratio. So maybe I could drop a set of gears out here and change one of these to a 58 and a 58. That may amplify. So I'm going to play with my numbers a little bit. But right now, if I'm looking at what I've got, this would be a good gear ratio and help me figure out what I want to do with my gear car. Okay. So your task now is to kind of think of how do you want your gears to play out. Remember, the key is getting this last gear in the spot you want and then working really kind of forward. That's kind of how I've always done my gear cars is I know I want a gear on the back wheel. Where do I want it? And then I kind of work my way forward. But before I get to this drawing, I do multiple sketches, just paper napkin sketches, rough drawings, to get the gear ratio I want, and then I get the formal drawing put together that will go to SolidWorks. Okay, hopefully that clarifies and helps with the adding into the 2 videos you should have watched on your gear ratio. What I want you to do now is spend some time calculating out some gear ratios, sketching some ideas, and getting a gear ratio put together in your mind and in a sketch. And then the next video I create will actually begin developing my gear train and showing you how to put that into your assembly and use your GearMate tool. Hope this helps. Good luck. Talk to you soon.